Okay, Tina, I think we can start now.
Okay.
Okay, thank you everyone for registering to this webinar. It's a new webinar from GMI. So we start with the life cycle for SEAL applications. Let me introduce myself and before Tina. So I'm Andras Poro. I'm working for GMI about, from about 5 years. And I'm responsible for European market and also key account for major customers. About Tino, I have to try to reduce as much as possible because Tino is a very competent person, a senior functional safety expert and trainer for safety instrumented systems for the TÜV Rheinland. So he's a course provider. He joined the program from the first year in 2005 and is currently number 2 on the list of all trainers of the TÜV Rheinland website. Really impressive numbers from Tino. Probably a lot of you know already him, but maybe you heard something. 177 trainings already he did during the years, 177. 2,378 students were attending to the trainings. 80% passing rate. So he has a very long experience. I've seen a lot of you that already know Tino, and so from maybe his traveling passions, maybe participate in some seminars or courses. Maybe in this COVID time, we stop organizing the functional safety courses. Maybe we talk a little bit later about that, but we start again maybe in September with the new courses. In the meantime, of course, we try to collect people and talk with people with these seminars. Okay, let me spend a few words about the GMI, so the course organizer, or maybe the webinar organizer at this time. So the company is known in the market for intrinsically safe solutions, SEAL certified devices. We are based in Italy. We have 40 years experience about, and with the internal production. We are in oil and gas market. We are talking about, we are working hazardous area application and SEAL safety applications. Let's go to the next slide, Tino, next. So this is a product range. So we have intrinsically safe isolators or barriers in our portfolio, safety relays, standard isolator, SEAL also in this case, safety power supplies, multiplexer for temperature, termination cards for DCS manufacturers, HART multiplexer, protection, surge protection, indicators. And also the last bullet is not really a product that we are proud to say that is our safety manual. We printed out more than 25 copies in the years, and we gave to all our customers free. So if you maybe any of you need one copy, just give us, let us know, and we provide you a copy, either paper or electronic format. So next. So our goals is to guarantee the very best standard in the market. We have our product certified for different application in the market. So we have certification for Europe and USA, of course, for ATEX, ICX, and also we have a certification for Russia, for China, for Brazil, for Japan, for India. So, and also DNV certification. We are proud to say that we try to to complete our portfolio with a major certification, accreditation that in the project is needed. We invest a lot in our R&D department. So we have a new plan for new products for the future. So we are non-stopping development. And also we provide 5 years warranty for all our products. So next. So as we say, we produce in Italy. We we have a state-of-art technology, complete traceability for all components, and full testing of all products. So it's let's say really automatized production, and also we are socially responsible for the product and for people working within the company. That is about the headquarters. It is in Milan, but the next slide we can also see where we are. So we have a direct presence in all continents, in America, in Japan, in Asia. We have in Singapore, in China, in Dubai. Also in Europe, we are working with our subsidiary in France. But we have a lot of local dealer partners that are supporting us with the products and say with quick delivery, especially when the product is needed in a different part of the world. About the topic, which is functional safety, we are, as we said, we are course organizers. So we organize about 18 courses per year, also in-house for big companies when is required, and by the, let's say, the help of Tino Van de Capelle here today. Another question, yeah, another slide. So an overview about the customer we are present. So we have end users in our customer database, and the user that can approve the product. We do have system vendors that integrate the product in their system. We have EPC, engineering procurement customers, contractors that they are also accept our solutions, the system provided by the system vendors, and OEM customers that use the product within their application. Can be a valve application, can be maybe a gas turbine in most of cases. So that is an overview about our customer portfolio. That's practically also. I leave Tino to the topic of today. So there will be about 12, 14 slides with the details. And then we can start with the question that you expressed during your registration. And I repeat again, you can also make some questions on the Q&A button you see on the bar bottom of your video. So let's start, Tino, with you. Thank you.
Thank you, Andrea. And welcome to all the participants. I see we have about 31 people currently. That's about 50% of those who registered, so it's not too bad. Many names I have recognized. I mean, all the names from previous trainings. So for those who have been trained before, I would say you will not learn much new now, because it's more like a summarized version of the 61511 life cycle. We selected a few topics. I think in total, functional safety webinars, I still call it seminar, but webinars with GMI, we have, I think, about 10 or 11. And this is the first one. So we have in the next coming weeks and months, we have all the other ones following. The idea is to have like 20 minutes talk about a topic more in detail. I mean, more in detail, more like a brief overview. But then some of you have already in the registration phase, you actually asked me already some questions. So the majority of all those questions, I will try to give you a verbal answer after the presentation slides. So in total, we have about an hour, and let's kick it off. So for all those who haven't followed the training, you shouldn't panic, because I think the fact you log into a webinar to talk about the life cycle means you show kind of an interest that you would like to know maybe what is the life cycle all about. And as Andrea was saying, I have done too many trainings to try to remember them, but I have been on board with functional safety from the real beginning. And I thought I will start here the slides with a timeline, where you can see here on the left bottom corner. It started in the USA with the ANSI ISA 84.01. This was in 1996. Brief summary, that was the first life cycle model in a functional safety standard, or call it a safety standard, which they released in 1996. And 1 year after, they released in the IEC, they released the 61508. And the 61508 is dominated by, or say, is specifically written when you want to develop a product with electrical signals, electronic signals, or you can program it. So it was mainly focusing for the manufacturers, and in an abbreviation, we will call this the EEPES. Then we move on to 2004. The topic for today is a 61511. Before edition 2 was out, that is edition 1 we show here on the top left corner. It was a 61511 released in 2004 that was made a one-to-one copy by the ANSI ISA 84.01 with one small exception. The small exception was that back in USA, the ISA 8401 accepted the first edition of the 61511, but they added the grandfather clause. And the grandfather clause is referred here at the bottom, which is the Code of Federal Regulations from OSHA. That is here the correct reference number. Of course, as you can imagine, in 1997, I'm pretty sure that those who have been around in the industry at that time will recognize that the instrumentation, the type of systems, even the computers, even our mobile phones we were using back then were a lot different than the ones we are using now. That means also the standards they have to evaluate with all the new products and all the new material, which is evolving and getting more intelligent and more complex. That's why we had in 2010, we had the edition 2 out. And for those who have maybe joined the training before, you will recognize here between brackets, that's like specific for the standard. Whenever someone asks me something about the 61508 edition 2, let's say 90% of all the questions are always related to those what I'm mentioning in here, which is it either road 1.8 or road 2.8? Those are specific system architectures based on certain conditions. Or is it proven in use, which is this road 2.8, which was introduced in 2010 by the 61508, or is something to do with the systematic capability. And the reason why I brought it here into these brackets is because that will be one of the issues when we will talk today about edition 2 of the 61511. Now, what is now the 61511? That's a functional safety standard for the process industry. Process industry means oil and gas, chemicals, petrochemicals. What is new by the 2016 release of the 61511 is also pharmaceuticals and food and beverage. So here we have the 61511 edition 2. Again, it's for functional safety if you want to build an SIS. For those maybe on the attendees list who are listening in now, if you do not know what an SIS is, it means a safety instrumented system. So it's going to be like a collection of sensors, like your transmitters, your pickup devices, or your instrumentation at the front end. In the middle, you're going to have most likely like a logic solver, enabled to solve your interlocks or your logic. And at the end, you're going to have your final elements. Your final elements mainly is going to be valves, going to be either like a shutdown valve, it's going to be a fail close valve or a fail open valve, or it could be even a motor control center controlling a pump. Because safety, although many people try to address safety very difficultly, I try to address it just the opposite. Safety, it's all about you turn something on or off. You open or you close. So you only have two different states. And it's all about the reason of the standards is, will that state change be happening when we need it? So there will be all kinds of things in the standard, like how to maintain it, how to prove it. And some of the questions that came in earlier for the registrations will address some of those issues, so I will not handle them now. I will wait until I will go into the Q&A. And last but not least, back in USA, the ISA over here, those are the symbols, which I actually forgot to mention, but I think you figured that out. That's here the IEC logo, that's here the ISA logo. If I go back to the last one that was released in September 2018, it is the old ISA 8401, the one from up here on the left top corner, and you move down to the right bottom corner, they now call it the ISA 61511. So what I have done back in USA or with the ISA committee, they actually accepted the edition 2, And the edition 2, as you may have been picking up maybe here, we have two different dates. We have 2016, 2017. Very briefly, 2016, there was a release out that needed to have some, let's say, some modification, some correction, because there were a few mistakes in there. That means that we had a corrigendum out later in that year, September 2016. And then the full-blown is the consolidated version, which is called Amendment 1, August 2017. So for all of you out there who are using the IEC 6.15.11 standard, well then make sure that you are using 2017 release. And for all those who are joining us from the USA, who are maybe more addressing to the ISA 6.15.11, well then I'm pretty sure that this is here the document, September 2018. From there onwards, you will find the correct version. What is now the edition 2 all about? And again, in a webinar of 20 minutes, I can certainly not explain what is the whole intent. I will try to summarize it for you. So we have here three different parts. As you can see here on the bottom right, we have here the 6.15.11 part number 1, which is this one over here, which I already mentioned, is now the Amendment 1 2017 from August 2017 release. What is in there? That's the normative section. A normative section means that anyone that needs to show compliance with the standard of 6.15.11 as a minimum will have to prove compliance to the normative part, which is section number 1. And there you will see the framework, food safety management, you see the hardware section, see the application program section, you will see the how to do the verification, validation. So let's say all the entire description of the life cycle will sit here in this part number 1. Part number 2 will be the informative requirement. An informative requirement, as the word English is saying, it is informative on top of the normative part. In simply English, I can just say that part 2, let's say, intention was to try to explain how to read, understand, and treat part number 1. That is what we say over here. It provides you guidance. And part number 3, that is the other one. So as you can see here, part number 3 is about 100 pages. Previously, part 2 is about 200 pages, and part number 1 is about 84 pages. So you're talking about 400 pages maximum of text. And part number 3 has not much change compared to edition 1, but there you will see guidance like on how to make your cell selection, how to do your risk reduction, how to do LOPA as an example, how to do systemic calculation of dependencies of your systems. That will all be in the informative section in part number 3. Right, jumping right into part number 1. In a nutshell, the life cycle itself is performance-based, means they will give you some ingredients, they will tell you how and what to do. Often not, they will tell you exactly how to do it. They give you a few ideas and they give you a few items, but you still will have to perform it. So it's not a prescriptive standard that you can follow black and white. It is more giving you like a mindset, and you still have to perform and able to achieve a kind of a quality towards functional safety. In edition 1, many of the should commands or the nodes, they became a shall command in edition number 2, which is here not so important on this short webinar. 2 fundamental principles remain. You still have a life cycle from top to bottom, and I got a slide, of course, coming up on the entire life cycle. Here we show in the blue color all the technical requirements with the supporting parts. And here on the bottom part, we see part 2 and 3, which are the informative parts, which we have just mentioned. So 1 is the life cycle, which is like a mindset on all your phase activities on how to do them, how to document, etc. Whereas the other one is the safety integrity level. And you probably have figured out, we have the majority of our installation anywhere between a SIL 1 and a SIL 2. We have the minority anywhere towards the SIL 3. And if you would have a SIL 4 in the process industry, I think then you should revisit an application. It's possible, always assumption, or as I say, exceptions always exist, but a SIL 4 is not necessarily needed for the process industry. Software programming in a safety PLC has now become, the new name is called application programming. FAT, which is your closer, paragraph number 13, has become informative, and all the references, of course, are towards the 6.15.08. Now, from a life cycle, I already mentioned, I call this a mindset. It's like a kind of a good ideas to tell engineers on a systematic way from concept all the way to your, let's say, your decommissioning. So from your process hazard assessment at the beginning of all the phases of your projects, all the way to the decommissioning, it's a step-per-step, a systematic approach that's called the life cycle. And then the performance-based or the SIL classes are being expressed in PFD. Actually, that's purely my personal opinion. I regret the fact that in this, let's say, all these years that we are trying to achieve functional safety, both with 61508 and with 61511, what I see worldwide, and as Andrea was saying, we do provide worldwide many trainings, meetings, webinars, seminars, etc. I notice still today that many people focus too blindly, purely on numbers, on PFD, on SIL. And if I talk about the other part of the standard, which is called functional safety management, and the quality on how you have achieved your activities and how you can prove that, they say, oh, no, it's a SIL 1 or SIL 2, look, I got a report here. And I say, well, that's only a very small part. I will come back on this later. But again, it's certainly not all about the SIL class and the PFD. There is a lot more on functional safety to take care of. Well, on this slide here, and I'm just looking at my timing because I don't want to be too late, although I only have a few slides prepared. I still see that I'm already behind schedule, but I will try to maintain schedule. So that slide over here is the life cycle. And for those who have never seen it, I will give you a practical example. Let's say you have a plant, you have a tank. In the tank, you have a, let's say, a hazardous product or a dangerous product. First of all, in phase number 1, we call this the hazard risk assessment. What is here the key issue? A team, which will be a multidisciplinary team, and some of you may say, oh yeah, we have done a hazard. Well, hazard is a kind of an example on how to identify what type of product is in my tank. And once you know what type of product is in your tank, then you can start to brainstorm. Then we call this, we will do a hazard analysis. That means that what kind of analysis, or sorry, what kind of information do we looking for when we are doing our analysis is one, is how bad it is, means the consequences when this hazard or when this product would start to leak out of your tank. And the second part is the consequences. Now, I can tell you now, and anyone who have done this type of business or have experience will recognize that for us as human interaction or human beings and human team efforts, it's quite straightforward, often with teams to agree on consequences. Opposite, it's almost impossible to agree on how frequent that event will happen. And it's about that frequency that is the key issue on the entire life cycle, because when you are deciding a SIL 1, 2, or 3, we are calling this a risk reduction. That means you are trying to reduce that frequency of that product escaping from that tank. That's the mindset. Then we are moving into phase number 2, which is the second block over here in the middle. And we call this the allocation to protection layers. That means if you have an existing plan, we're going to look at the existing control layers, and we're going to try to find out how many credit can we give for this one layer. And based on the credit we're going to give to this layer, then we're going to decide, do we need more reduction? Most likely, yes. And that's where you will come in with a SIL 1 or a 2 or whatever classification of a safety loop that you may need. And that's why we move into phase number 3. And in phase number 3, once I know what additional safety instrumented function protection do I need, then I have to specify it very clearly. And we specify this in a safety requirement specification, as some of you may know, as your SRS. In your SRS, that is where you will specify exactly with 29 items per one safety instrumented function. So one loop has, as per the standard in paragraph 10 of the 61511 part number 1, is saying you shall describe and you shall include, and they will list you 29 bullets. And I also agree that often we will not be able to fill in all 29. But my proposal would be you make a template and you try to fill in all 29 items if possible. Because all the ones you will say not applicable means in the future, whoever was not involved in this project reading your document will think that that particular information for that particular loop was not applicable. And it may not be applicable at the time of a design, but it may come more applicable later on in his life during the lifetime of your plant. Design and engineering, that's phase number 4. Here, it's mainly the topic that we will look in. How do we design our plant? Do we need 1 valve, 2 valves? That means you will talk about a certain architectural constraint. That architectural constraint is referred to a table 6, and table 6 remains the number table 6, but the table 6 has changed completely between edition 1 and edition 2. Again, I cannot go too much in details, but I will very briefly tell you now that table 6 is row 2H. That's based on your prior use for an end user. And if you don't have prior use for an end user, there are 2 other options left. One is called the row 1H, that's the 1997 edition 1 from the 6/1508, which is still applicable in edition 2. Whereas the last option is row 2H, this is called proven in use. So summary, end users prior use, manufacturers proven in use. If you don't have all that, you go back to the theory and you're going to say, who has made analysis on my product based on a row 1H. Now we are moving into installation, commissioning, and validation, which is on phase number 5. That's here where you go on site. Of course, before you go on site, let me maybe just rephrase this. I go back to phase number 4. Here you see number 13, that is your FAT, your factory acceptance test. Before you're going to ship it on site, we have to do normative required by edition 2, we have to do a factory acceptance test. And I skipped here stage 1 and stage 2, and I will also skip stage 3, 4, 5. I will mention this a bit later in my text, but those 5 stages, new by edition 2, every single individual one is now a normative requirement by the edition 2 of the 6/1511. In a nutshell, you shall carry out by a senior independent, of course, competent assessor. He needs to carry out a functional safety assessment, and for stage 1 to 3, independent from a design team. For stage 4 and 5, independent from the operator and maintenance of that same SIS. Now we were here in installation commissioning. You go on site, you do an installation commissioning and a validation, and there you can do then the stage 3. That is before you introduce the hazard in the field. As some of the American people that have logged into this webinar may recognize, you most likely will call this the PSSR, which is your process safety startup review. That's known here as stage number 3. And then we go to the ops and maintenance. That means that's the longest phase in the complete life cycle. Your plant and production, your lifetime may be 20 years, 30 years, whatever it's going to be. That means that is the long period. What is new by edition 2, it's a periodic assessment here by stage number 4. Now, periodic is not defined how frequent is periodic. That will be most likely, depending on which country, which region, but most likely your regulatory body will give you a specific time. Without mentioning names of regulatory bodies, I give you a few examples from the industry of periods. It varies anything. The shortest one that I heard was 18 months. The longest one today that I heard was 5 years. So majority sits between 3 to 5 years. That's what we see as a periodic assessment for stage number 4 for the end users. Modification, that's stage number 7. Basically an end user that has an existing plant. Or the moment you moved all these phases and you are here in phase number 6, the moment you enter phase number 6, the moment you started up your production unit and you want to make one small change, that one small change will be called for us a modification. In a nutshell, a modification, most of you will recognize an MOC or management of change procedure. Well, in a modification procedure now, by addition to what is normative required, you shall carry out a functional safety assessment, stage 5, before you start the modification and after. So basically, you can carry it out twice. And last but not least, that's decommissioning. Now, I was trying to give you a little bit of an example from phase 1 all the way to phase 8. Overall, what you see here, which is phase number 10, that's functional safety management. There are some specific items changed in this, but we do have a webinar specific on functional safety management. Then also here we have the safety lifecycle structure and planning. That's more like the scheduling of all this activity, documentation. There's no much change between edition 1 and edition 2. And last but not least, we have the verification. The only small change by edition 2 in verification sits here in chapter 12, which is your application programming. So when I'm jumping back in phase number 4, assume that you buy safety PLC, you have your person keying, or let's say coding or writing your application programming. What is new by edition 2, we call this the 4I principle verification. The person who wrote the program cannot make his own verification of the program. It must be an independent, competent person, different from the author, and he or she shall show what evidence, or let's say what method they have used to review the previous person, his program. Right. If everything went well, my entire explanation is here summarized in this slide. So you deal with activities and responsibilities. I forgot to talk about responsibilities, but clearly function safety assessment is all about independencies. You cannot be the person doing the work and make your own verification and also your own assessment. That doesn't sound right in safety. So in terms of a safety culture, we are assigning activities, responsibilities based on their duties, their background, their competencies, and also we will have an independencies in terms of people who can actually do the review, the assessments, or the expert judgments, as we call them. FSM, let me go back. FSM stands for Functional Safety Management, Verification, Validation, Assessment, and Audits. All of it, one main target, we want to try to increase the quality, to decrease the human failures. Regardless if you have a SIL 1, 2, 3, we don't care in these topics. This is purely based to try to achieve a quality on your activities. Summarized, we can summarize the 3 first phases. We call this the analysis phases. The middle ones here, we call this the realization phases, where we actually realize we are building, we are designing, we are developing, we are coding. We go on site to installation commissioning. And the last one here is where most of the end users, their life is. That is ops and maintenance, modification, and decommissioning. Regardless if you are active in phase 1, 2, 3, or a mix of them. Those who are having the number 4 over here, there are the generic sections or general sections. So function safety management is for everyone. Not only for the manufacturer, not only for the EPC contractor, not only for the safety PLC manufacturer, it is for everyone active in this life cycle. And that's a new thing by edition 2. Very briefly, function safety management, the left one here, any supplier supplying a product or a service shall have a function safety management plan in place and shall prove how adequate he is using it. In simply English, it doesn't make sense to create a monster of a procedure for function safety management if you cannot follow it. That means you will have to prove how adequate you can follow that FSM in your project. Now, what I will do in terms of trying to save a little bit of time for more Q&A, my story from the beginning is all captured in here. So here you see your phase 1, 2, 3. That's all the text, which I will not repeat again, but that's all the text for this phase 1, 2, 3, which is your analysis phases. The next phase is the realization phase, which is 4 and 5. That's again all the text which is here for those 2 phases. The one I skipped so far is here clause number 9, and clause number 9 means this is the other means of risk reductions. That's what we said over here. Now, maybe I back up one slide because I just see something which I forgot to mention. What is important here is at the end of these 3 phases, you see here we have a stage 1. That's what we have mentioned here on the bottom. You shall carry out, and I say you shall in English, so not you should, but you shall carry out a functional safety assessment after your safety requirement specification is written. That means before you issue the document into the project team to build the projects, a senior independent expert shall make a judgment based, of course, on his competent experience that the SRS that is due to be sent out or due to be issued is complete and is correct. That's a normative and an important stage to do. I see here stage number 2, that's here one in the middle. That means after you have done the FAT, means your factory acceptance test, you shall carry out the same kind of senior competent independent assessment judgment, again independent from a design team, and the same for stage number 3, that is before you introduce the hazards in the field. And last but not least, we go to the ops and maintenance. That's you, Mr. End User, for those who have joined. That means that for an end user here, stage 4 is repeating, it's coming back. So periodic will be defined most likely by or the regulatory body, or maybe if you are belonging to a large corporate, let's say, company, maybe the corporate office will decide that for you, but that is something that I cannot answer here, what is periodic for you. Now, stage 4 is periodic and shall be carried out, again, senior competent independent from the same operations and the same maintenance. They do not say you need to have an independent company. Some companies do that. Some people hire, or some companies hire some independent consultant, senior, competent, whatever. But they also said clearly that if you have a large company with many different teams for different SIS, there is no problem to make assessments from each other's SIS or safety instrumented system. Last but not least, stage 5, before and after the modification, I already mentioned that. Here, I will be very brief. It's all about trying to increase the quality, decrease the human failures. That's the whole topic of our food safety management. In safety, we don't do anything before it is on paper. That means any one of you have done something without proving that it was in a source on paper, well, it cannot be good, because you cannot prove you have done it correctly, because you have no reference document. So anything in safety, always paper, paper, paper. Of course, paper must be accurate, must be as built, and the word as built, as people will know that follow the training course with me, there is no such thing as built 100% correct documentation. It's almost nearly as built or something as built, but not 100% correct. And that's not good for safety culture. So every activity that we have done needs to be verified to prove we have done it correctly. Summary, as a summary for the life cycle, it's not all about a SIL number and a PFD. There is more to that. I hope in this 20 minutes that you have a bit of a flavor. It's not just about a SIL X with a PFD X. It's more about how we have done it, how we can prove it, how we can increase the quality, minimize our human failures. It's not automatically achievable. It's performance-based. It's here between your two ears. You can buy lots of books, you can follow lots of training courses, but you still have to do it. That's what I'm trying to say. And I open it up for Q&A. What I have done is, for those who have sent in some questions and answers, you may recognize some here, and I will handle the very quick ones first. Can we attend multiple webinars? What do you think? Of course, you can attend as many webinars you like. So the first one is answered. Second, IEC 61511 is a guidelines for...
Tino.
Sorry.
Tino? Yeah. Yes, we are organizing different webinars dedicated for functional safety, dedicated for ATEX application, it means zero barriers, and also for safety relays. So you will find all the details in our website, where there is a live webinars section. You will see the program is a going program, so you have to check not daily, but let's say weekly, and you can register. However, you will be so advised by on LinkedIn, so you can check on LinkedIn. If you follow GMI, you will find all webinars that will be displayed, so you can register there. We set a limit at 100 people, not more, because we are waiting. So there are basically questions in every webinar, so we'd like to answer live to this question. So that's why we set to 100 people. Okay. Definitely, you can attend to multiple webinars. Good.
Very good. As Andrea was saying, not only functional safety is discussed in GMI, the core business, of course, their ATEX interface and materials. So there will be many webinars also on those topics, which will not be me, because I'm only handling here the functional safety 61511 topics. Right, jumping into question number 2, and I do know the person who has been sending me that.
Was Paul. for the second question. First was Frank, the second is Paul.
Okay, so the guidelines for the SAS maintenance, well, as you may have seen, if you would have read part 1 of the SIG 511, there is no such clear, let's say, bullet list of guidance giving for maintenance. But of course, what do we look for in maintenance? And again, this is not very an easy question. I'll not be able to answer it completely, but in what type of parameters do you check? Well, I think in a very simplified answer, what do you need to check is, of course, first of all, you have the useful life of your, let's say, equipment. That is the useful life itself that the manufacturer will define for you. You have the lifetime. That means that is the expected time that you expect to use that material. And then you have your risk reduction in terms of, let's say, based on your proof test coverage and your proof test interval, what type of risk reduction do I try to achieve? So clearly your proof test interval / coverage, but mainly the interval and period, needs to be, of course, smaller than the lifetime. And hopefully, in theory, your lifetime is shorter than your useful time of your equipment. Of course, if your useful time of the equipment is only 5 years, you want to run your plant for 20 years. That means in theory, every 5 years, you will have to either replace the equipment or you have to do a refurbishment of the, let's say, mechanical part like a valve or something. So what parameters do you need to check? I was trying to keep it simple, and I noticed myself I was going too much in details already, but to keep it simple, what parameters do you need to check? You need to prove that your safety function is still working in your process safety time as expected under the hazardous conditions, which is not always possible because many end users are not allowed to do testing online. They have to do a shutdown, a plant shutdown after 5 years, and they try to simulate, and we try to simulate, they try to estimate. So it's all like assumptions here, assumptions there. But basically what we are trying to prove is that my safety function will work when I need it. Now, how often? It depends on your risk reduction factors. It depends on your quality of your equipment. Logic change, well, that's the first wrong thing for me. You never change a logic when a plant is running. You always modify a logic. A change does not exist. A change exists when the system manufacturer has not delivered the product yet. That means the person who coded the, let's say, coding the interlocks in the safety PLC, he is the changing. He can do changes all he wants. The moment he compile, he deliver, it's running on site. You do one small change, and we call this a modification. So I know that every system PLC manufacturer in safety, and I've worked with a few of them, right? They always have the same question: can we make some modifications online without shutting down? Well, the standard is very briefly, the standard is not talking about specific safety PLC manufacturers, but the standard gives you the following advice. If you can guarantee your safety and you can guarantee your functional safety during your modification, go ahead. That means if you cannot guarantee that, don't do it. You can do it only when you are in shutdown. Question number 3, and I look at Andrea. Question number 3, what is a true functional safety assessment? Well, I think I have already answered a bit of the true functional safety assessment, especially design and implementation. That stage 1, 2, 3. That means those 3 stages are by a senior, competent, independent person, independent from the design team. What about the mandatory or validation after the SIS hardware modification? Well, I do assume that that question is related to a end user existing site, existing installation. If you do a modification on the hardware, you have 2 options. Assume that you are replacing a broken instrument with a like for like. A like for like is not handled the same as a modification. Would be different that you cannot find this type of instrument anymore and you have to buy a lookalike from a different vendor, which is nearly the same but not 100% the same. That means then we are focusing on, we are modifying some activity or some performance maybe in my safety loop. So then here we have a whole different ball game than with a like for like. But what is about mandatory? The bottom line is you have to prove that your safety function is still working as per design requirements. And although you only ask here for SAS hardware, I already answered the following. Even when you do a modification on your logic, that means on an existing safety PLC program on a live plant, at the end of the modification, you have to prove that your system has no unintended side effects. That means you have to prove that whatever your modification impact could have, it has not negatively impacted any other function of that safety PLC. You will provide any course certificate for a webinar. That's not a course. I mean, I don't even know if you're listening or if you fall asleep or not. So no, there is no course certificate on a webinar. If you follow a course, of course, we have many courses and we have many different certificates, but that's a different topic. I have one question.
Yeah, there are two live questions. One is from Kuduba. He's asking, how shall I get a safety book? Kuduba, yeah, we will contact you later. So your question is stored in the system. And so we'll contact you later. We'll provide you the information to get the book. And then there is another one from Farnas.
I know her. And,
okay. Are there any good references for PTC for different equipment groups? Except
proof test coverage.
Also, how can we improve the proof test coverage for ESD valve, for example?
Farnas, know that. That's a very excellent question, which I would expect from a student like Farnas. But proof test coverage, you are right. In the NAMUR guidelines, there is a very good guidance giving, or I say a very good examples giving. Besides that, there are many different standards also, but specific for ESD valves. And I do remember we may have talked this when we met last time in November of last year. The standard is still not out. We have a new functional safety standard coming specific for ESD valves or for safety valves. I actually wrote it down. That's from Technical Committee 69, TC 69. It's going to be a SINELEC standard. I have no number for it yet, but it's going to be functional safety for safety-related industrial valves. And the moment that this would be coming out, of course, then hopefully there will be some more guidance in there. But in the 6.15.11, there is no good guidance for that specific questions in there. So I fully agree. But we also have a webinar later on. It's not ready, but I got a webinar on proof test coverage where I may try to go a little bit more in detail. Right, let's just move to the last question on this slide, which is, I have one question, what is the reliability of a fuse in a SIL system? That's an interesting one. I do assume that you're talking about, let's say, a glass fuse in a marshalling cabinet. What is the reliability of a glass fuse? Well, I'm pretty sure, I hope so, there is no SIL classified glass fuse available on the market. I mean, you always have maybe a vendor trying to charge you some money for some additional, let's say, certificates on maybe some equipment, but I would not assume that there would be anyone, let's say, challenging that you would put a SIL class on a fuse. Now, fuse, what is a fuse function? The function is to provide you a certain current to a certain voltage to a certain final element or to a certain instrument. That means if the fuse is blown, and in the majority of all the, let's say, safety loops, we go for de-energized to trip. That means if the fuse would blown, okay, then you would lose the energy, and as you are a de-energized to trip, you will cause a spurious trip. Assume that your fuse was blown, and you actually go to a, let's say, you go to a phase where your safety function is activated for no reason. That means spurious or nuisance trip, right? That's what the end users certainly do not like. That doesn't make your safety loop for the standard point of view unsafe, but it's no longer available because you lost the power. Of course, if you would go into energize to activate like a fire and gas application, that's a complete different story. But as we are here with the fuse, a very short sentence, and again, we can hopefully do a webinar specific for power supplies. I don't know if some of the attendees here on this list are aware there are SIL compliant power supplies. And you may say, hey, you just told us you power off, you go to safe. Well, what is now the opposite effect of a fuse that cannot blow when it needs to blow? In other words, you use a power supply, creating an over voltage or an over current, and the fuse is maybe not selected correctly. It's maybe too slow, or maybe it is taken way too big. That means, in other words, the fuse cannot blow and the overcurrent is going to your instrument, is burning your instrument, you cannot shut down your loop. That becomes dangerous. And therefore, we have specific power supplies on the market, and GMI is making a few of them, and they have a SIL 2 or a SIL 3 on them. That means it's all about, when you talk about safety and power or voltage, it's all about, first of all, under voltage, because having a low voltage, your field will not be able to actually act because you have an under voltage, or it's all about the over voltage. And when you have a SIL, let's say qualified power supply, they will supervise especially those over voltage and under voltage. And you can say under voltage, that's an availability, fully agree. But over voltage, that could be a very dangerous item. Now this slide.
We
yes,
do have other two questions live, so
okay.
Answer. What is the difference? This is from Vikrant.
Assessment and audits. Okay.
Between functional safety assessment and safety audit.
Okay.
If different elaborate audit.
Yeah. Actually, basically the principle is the same, Vikrant. So the functional safety assessments, as they are described today, edition 2, it states 1, 2, 3, 4, 5. Functional safety audits, it is more like, in simply English, we call it more like the helicopter view. Do you have a functional safety management? Yes. Do you follow it? Yes. We will not go into details to see what is the quality of the FSM. We're more worrying about, can you prove you follow it? So it's more like from a higher level. It's also periodic returning, and that's called the audits. Whereas the assessment, it's expert judgment based on technical competency, independent from the activities, and they have to make a judgment on how correct you have done it. Whereas the audit, it is more like the paper trail. Do you have the procedures? Can you prove you follow it? That is more like the audit. Right. I'm getting more questions than I can answer, but I will do my best. Okay.
There is an anonymous attendee, so no name.
Yeah.
How we register in the course? Are they available free of cost?
What do you think? Are they available free of cost?
What? Yeah, webinars.
Smile, I don't think so. My courses are not free of charge. The webinars we are doing now is GMI paying me to provide you a free webinar. So with all respect for GMI, they are helping, educating the world by sponsoring me, by actually helping you to learn a little bit here. But the courses, no, they are not free of charge. But they can be, of course, arranged. I mean, arranged to whatever price we can agree upon. Okay, one more question from Lubo, and then I want to finish here that slide I have in front of me, but I got a question from Lubo. Hi, Tilo, is there any direct relation between 61511 and the 61512? Well, that's always a challenge. Eh? I have to admit, I do not know immediately what the 61512 is. I will have to pass to this answer, as I do not know what the 61512 could be. I don't try to remember now. I will have to look it up. So
let you know.
Apologies.
Sorry? We live.
We can send you a short, brief email summary if we do have your email address. And then the last one from Mohammed, the difference between 61511 and 61508. Let me tell you what is equal. SIL 1, 2, 3, 4. What is different? All the rest. Means 61508 manufacturers, 61511 that's for the end users. The concept is the same, the framework is the same, but the nitty-gritty little things are all different. That means, yes, the framework of 61508 needs to be followed, enabled to go into the 61511. So there is a huge difference, which cannot be just answered here in a webinar in a 1-minute answer. Back to my slide. Which could be the best approach to control vendors for quality and safety critical subjects? Sorry, that is the quality of the vendors. Well, I do know the person who has sent me that question also
recall, I guess.
were ex students to previous training classes before. Okay, to try to be polite here and in this answer, I would assume, or sorry, I would propose that the best approach would be to control the vendors, to ask him, Mr. Vendor, do you have a quality management scheme? If yes, prove it to us. Showing a certificate of ISO 9001 is not a proof, that's a paper. Ask him to show you how they are using their quality procedure for the product you want to buy from them. That's one. Number two, functional safety management. Ask your vendor, do you have an FSM? Because I do assume the vendor is selling you a safety equipment based on the 61508. That means he also will have to have a functional safety management scheme. Again, same story, showing you an FSM is not the question. Show us the FSM procedure and prove to us how have you used it in terms to develop, maintain this product you're going to sell to us. That's a whole different question. And last but not least, as you should know from the training, what is mandatory required by any vendor in safety for IEC 61511, it's a safety manual. So a safety manual is a normative requirement since April 2010 that any specific product shall have a safety manual to give you all kinds of information to the end user, how to use, how to install, how to proof test it, coverage, etc. That's all part of the safety manual. And which is the impact of this life cycle management of a complex system? Well, here between brackets, complex system, I assume that you try to combine different items together. That means in theory, if you use a complex system with 10 different vendors or 10 different, let's say, interfaces, every single 10 will need to comply to all those items. I think we have to, let me ask you a quick question to Andrea. I've seen that the invitation was for 1 hour. Can we run over 1 hour or are we blocked?
Yes, I think people, we say
okay.
more.
I do not know because it was organized by your IT department. I thought they have given us 1 hour.
No problem. We can, I
will keep on talking. No problem.
Yeah.
So the second question here on the slide, which standard should we consider in the deep water application? I think they should say world. Maybe it was my spelling mistake, or maybe I just did blindly cut, copy, paste. But you are talking about this, for those who are not familiar to this question, that's about a manufacturer from Italy. And they are making this pressurized, let's say, rooms or chambers where divers, enabled to climatize to the pressure, will have to go in such a chamber. So it has to be very precisely controlled in terms of pressure, okay? And clearly the 61508, that's specific for EEPES. And I do know on that chamber, like your pressure control, all that, that can be specific instrumentation related to the 61508. But the question was, will our chamber that is doing this pressurization control, will this be under the umbrella of the 61511? I would say probably not really, although it's also kind of a process. It's not the classical oil and gas or the petrochemical or chemical, let's say, installation that we are addressing with the 61511. However, your safety function, as I do remember, I discussed with one of you, and I cannot remember who was the one asking me this specific question here on the bottom. You also handle with a safety function. You also handle that you measure a certain process variable. You try to control it with an interlock with some alarm limits. And there you have a final element to try to control that pressure. So it can be either a control of the pressure, it can be either with a high or low trip or whatever. But that means you also have a kind of a similar, let's say, application loops like we do in the process industry. So is there some, let's say, some lookalike as a 61511? I would say yes, but it's not a clearly one-to-one applicable. And I hope with this I answered your question. And I have one more slide, which is this one over here. Interested to achieve the relevant certification in functional safety, what course do you offer? Well, that's a good question. We offer anything from 61508 specific training course to 61511 specific training course. And as Andrea was mentioning, GMI is a course promoter / organizer. They are promoting the course for TUV Rhineland, which is this competency review program, which is on the market 2005. And I heard that Andrea was saying in the introduction, I'm number 2 on the list. Well, in the meantime, I'm number 1 on the list because the other 3 are no longer on the list anymore. So from the 4 original, 1 passed away, 1 retired, the other 1 quit. But on board to 2005, we have about 15,000 people in the industry with the functional safety engineer for SIS program from TFE Rijnland, and that's the main program in terms of certification that we will actually offer. The other courses are not giving you a, let's say, certification from an accreditation office. It will be certification from GMI/TVC. Right, how do I learn more about the 61511? That's actually a very, let's say, clever question, because I do assume this is coming from someone who is maybe new, and everyone has to start in this business. Well, my advice would be, hopefully your company would provide you with the official release edition 2 of the 61511. And I would try to read it from corner to corner. That means like not read line per line, because it will be, you will be struggling if you read it the first time. But if you start, take part 1 with part 2 next to it. And every single paragraph referred in part 1 will have a cross-reference in part number 2. And part number 2 will say, how do I read or understand what part number 1 is trying to tell me? That's number 1. Number 2, of course, you can follow many different training courses worldwide, even online training courses, or you can follow many different webinars. There are many free webinars available already on 61511. There are many webinars where you even have to pay still for. It's like a mix. Plus, last but not least, there are many good books. And one of the books, which Andrea already mentioned, the SIS manual, SIS manual, which is now in the 4th revision or 4th edition. There are about 50,000 copies of that book worldwide being distributed. And if you're interested in one of those books, well, then you have to send us an email, and then Andrea can make sure through GMI that the book could be sent to you, or you can have an electronic copy. I'm not saying the book is the best, it's a summary, because the summary on 61511, that's chapter number 7. It's kind of an executive summary that I wrote 2015 when edition 2 was not being released yet. It was like, what is my view on the edition 2? In the meantime, I would write things already different, because I learned in the last 4 years many other things already. But there are many other detailed books available on the market. If you Google it, I'm sure you're going to find too many to read in 1 month or in 2 months. Right, question number 3. How the yearly maintenance schedule can be increased when we have a defined proof test coverage interval. I have to smile when I read it, but I'm trying to not to smile. I said, okay, that's a very valid question. That's a very, let's say, normal question that often production people / let's say production supervisors, management will ask us if you go on site with the end users. Now, unfortunately, you have to step back of this. And if you remember what I explained earlier in one of the questions, there are 3 topics. There are 3 topics that you have to be aware of. You cannot schedule a delay as this, saying, oh, we have done our magic calculation. The prediction is we have to test every 1 year with a certain coverage. Well, you have 2 options. If you can make a better coverage, most likely, the next time you will be delaying the interval, most likely still achieving the same, let's say, target, tolerable risk reduction as you're trying to achieve when you're doing your proof test of your safety loop. However, you cannot just decide it based on numbers. Let's step back and say, first of all, what is the useful life of that equipment? Now, answering without asking you the question, how many end users here on this panel list, or sorry, on the attendees list, know the useful life of their equipment today installed in the field? When was it installed? How often you have used it? And how can you prove that? And that's where we're going to start. So the useful life is coming from the manufacturer. Of course, the manufacturer has a liability. Like an example, GMI has some material. They give you a, from a liability point of view, they give you a recommendation for a proof test interval of 20 years. That means that specific component, useful life, most likely is 22, 24, maybe 25 years. But because GMI is a respectable manufacturer, they recommend to test before the expected end of life of that product is coming. That's the first thing. And you may have seen already a bottom-up curve. That's the horizontal life. We call this the useful life. Now, your plant design or your management, they will decide how long they want to use the plant. They may say, you know what, we bought this GMI safety relay, although GMI is saying that the useful life is 20, or we have to test in 20 years. Maybe my management wants me to use this relay for 50 years. Does that mean after 20 years you have to replace it by another one? Well, in theory, when you are doing your liability or proof test to prove it is still working the way it was designed, the theory and the standard is you can prove that the equipment is working as good as new. But everyone knows if I have a mechanical valve and you're closing your valve every week, well, I'm pretty sure after 5 or 6 or 7 years, as good as new, it will be as good as not working anymore. So those are things you have to be aware of. So the lifetime, that's decided by, let's say, the expected lifetime of your plant. And then when you have done your self-verification with your calculation program, many of you are using a sophisticated program, you're entering all that data, that is where you will see what is the expected proof test interval that I will have to prove that I'm still reaching my target risk reduction of this sill band. And that's what I want to answer here, okay? And last but not least, dear GMI, I'm highly interested in the proof test coverage approach for SIS final elements. Well, I hope you were already on board listening. I don't know if you are still on the panel because some people have already left. But we will have a proof test coverage specific webinar, that's one. Second, for final element, I do assume that you are meaning here final elements such as valves, can be butterfly, can be ball valve, can be gate valves, all of that. Let's give it the following summary. Currently today, in 2020, many manufacturers of valves, of actuators, of positioners, they have a certain evidence of a certain quality of a certain SIL X level. We all know when you combine all those different items together, it's kind of a puzzle. First of all, how can we use all these numbers together? And second, often for some of the parts, like the mechanical body of the valve, you may have zero information of numbers. So where do you start? And we all know that if you look on the existing papers, supporting papers, proving evidence, this is based mainly on the 61508. And it is fair to say the 61508 was not made for such type of equipment like a mechanical body of a valve, because it was purely made for electrical, electronic, and programmable electronic safety related system. That means for that reason, that's why we have this technical committee 69, which is Synelic, will bring out, hopefully by next year, maybe 2022, maybe there's also a delay of this COVID-19 time. I have no idea, but I would assume there will be a delay. There's always delays on standards release, but there will be a specific standard out for functional safety achievement on safety related industrial valves. And I'm really hoping that in that type of document will be a lot clearer, let's say, guidance for end users, maintenance people on how to test their final elements. Right, with this, we're gonna round this up.
You know, there are some questions.
Oh, okay.
Yeah, Koduba, that is, I would like to know the use of safety relays with the safety PLCs means benefit of safety relays. There will be another webinar next Tuesday at 11 a.m. European time, so dedicated to safety relays. So you're going to receive, I guess, LinkedIn if you register from GMI, and you can register for the participation.
Okay.
And there are other from Giovanni, okay.
Okay.
Interested
That's fine.
Webinar related to the functional safety FSA and the topics linked to the proof test coverage, etc. So also those webinars will be, as Tino said, they will be arranged soon. You will get informed. And from Ryan, maybe the last one. So is being a system integrator, what are the minimum certification requirements as per the standard for designing, logic, development, and implementation of SIS?
Okay, that's a good question.
The good question.
That's a good question on Rehan. So Rehan, system integrator, wherever you are based. If you refer, I do assume you are referring here to the 6.15.11 edition 2. Okay. Now, what is the minimum requirement? It is you shall have. There are 3 shalls. You shall have a quality management scheme in place. That means you will have your ISO 9001 scheme in place, and you have to prove how adequate you are using that. You shall have, which is new, that is the second one, this is the new one, you shall have a functional safety management scheme in place, and you shall prove how adequate you are using it for your projects. So in a nutshell, if you have a quality management scheme, most likely your functional safety management scheme will be integrated. Some people keep it separate, some people will integrate it, because you don't want to reinvent whatever was described in the quality management system. It will also be repeated then in your functional safety management system. But in the functional safety management system, will a lot be different items in there than in your quality. So we handle this as 2 different topics. So what is new by edition 2, 6.15.11, 2016 release, or in US ISA 6.15.11, 2018 release, you as a system integrator, you shall have a functional safety management scheme in place because you are a supplier of a product / a service, and you shall prove how adequate you are using that. In there, in a nutshell, you will show who is responsible for doing what is their education, means what is their competency with their education, their experience, and with their know-how. So you have know-how, you have experience, and you have the formal training. Excuse me. And then the last or the third bullet for a system integrator, you shall prove that you are supplying the product / service towards the requirements from your client. I think that is an easy one. I mean, you will get the requirements from the client, what you have to supply to, and you have to prove evidence that you supply towards that requirement. I think that is what we have been answering. All right. So any other question? I don't think so. Right. Good.
I think we almost finished.
Yeah, Andrea, I just want to summarize here with 2 or 3 slides. What can we help you with now? I mean, for those who are still online, we do have a kind of a lifecycle support. We have a team of people who can actually help you in all this kind of activities. I will not start to read them all out, but you can see it's clearly on the process hazard risk analysis, the LOPAS, facility termination and verification. So we can also do some verification or help you do the verification. Safety requirement specification, we have helped in the past some people with. And of course, one of the, let's say, more active activities for the last 2-3 years is functional safety management. And also we're doing more and more assessments live on site, end users on projects, etc. What is newer for us, also for us as a team as GMI, we have a other team, that's not the functional safety, but it's now the cybersecurity story. We have a team that can support with industrial security management and assessment, also for security management. And that's the second slide. The training was already mentioned. We support the TOV Rhineland accreditation competency review program, where we have the functional safety for the SIS. We do the CISEC courses, we call them. That's the cybersecurity courses. That is a new course on the program since last year. And by the end of this year, we should have run the first 4 courses in Europe, to start in Europe with. And then we also do security risk assessment, which is more like workshops we are doing. Customized in-house trainings, that's what we are doing here in terms of a webinar. So that's a free webinar. We also do customized in-house FS training and seminars through the GMI group. That's the book for those who know them, who doesn't know them. That's the 4th edition. And I will leave it here on the contact details. In the meantime, I'm looking here in the questions. There's one more question from Houthem Bahar saying, is fire and gas and firefighting are subject to the 6.15.11? That's a very good question, I can tell you, Houthem, because in the 6.15.11 new by edition 2, it is clear that there was a misconception that people were thinking that 6.15.11 is only for de-energized to trip systems, where a fire and gas or a fire system does not belong to because you are energized to activate. Now, what happened was, beginning of this year, 2020, February, there was a technical report number 4 from the IEC 6.15.11 being released. Not a normative section of the standard, fully agree, but to help you with the answer, the guidance on technical report 4 is saying that a fire and gas system is also part of the assessment according to the 6.15.11. So if it is directly mentioned in the normative section as energized to activate, the answer is no. It is indirectly referred in technical report number 4 of the 6.15.11. And I have no more open questions. Well, we leave this slide here. Yes, Andrea.
We can close. We say now 1 hour, 15 minutes. I think people are getting tired. And thank you everybody for participating. And let's see you soon on these webinars. Maybe different topics, not only functional safety, but also functional safety.
Okay.
Well, on my website, you can have an update about the next webinar, and also on LinkedIn, you can get all details about the webinar. Thank you again.
If you follow any of us, Tino or Andrea and Tino, on LinkedIn, you will see that we will also share what we are presenting. From my side also, wherever you are, I would say good morning, good evening, good afternoon, or good night, wherever you are. Thank you for listening. I did my best. I hope it was useful. And if it is useful, tell it to other people. If it was not useful, send us an email. Okay? Thank you.
Thank you. Bye-bye.
Thank you, Andrea. Ciao, ciao. Thank you.
Bye.